So go to your calculator, plug in g prime of 5 using the g of t function. Again, ensuring that you are in radian mode. And you get negative 24.588 or 587, depending on how you round it. So what does that mean? Well, it says use correct units to interpret your answer. So if you take a derivative of a rate, that is like taking the derivative of velocity, whiwhich gives acceleration. So that means that the units are in tons per hour squared. Because they were already in tons per hour. You derived it, so that made it another hour. So using correct units, interpret your answer in the context of the problem. Interpreting my answer in the context of the problem means I need to write a sentence about what that means. I need to write a sentence about what that means. And this means that the rate at which gravel is arriving, because remember G represents arriving, is that negative implies decreasing at 24.588 tons per hour at hour 5. Find the total amount of unprocessed gravel. So unprocessed arriving during the plant hours of operation. So the amount of unprocessed would be the integral of g of t, 0 to 8. Because integrating the rate at which the gravel arrives unprocessed for the 8-hour workday will give you the tons of gravel unprocessed. Why do I not need to add that 500 or think about the 100? Because all it says is find the total amount that arrives, not what's there at the end of the day, or not what's been undone. It's just saying how much arrived in one day. So in one work day, the amount that arrived is 825.551 tons. G of 5 is different. G of 5, so that's part C, is the amount of unprocessed gravel at the plant increasing or decreasing at time 5. Show the work. So now, again, we are given derivative. Derivative tells me what the original is doing. So if the derivative is positive, then the amount of tons is increasing. The derivative is negative, it's decreasing. So is the amount of processed gravel on the plant increasing or decreasing at 5? In order to find that, I don't need the integral, I don't need the derivative, I need the actual function done at 5. 5 is negative. It's decreasing. Because G of 5 represents the dull rate. So G of 5 is 98.14076. I took the original human function and put it in. Because the original function is the tons per hour, which is the rate of change. So what that means is at hour 5, the rate of change is 98 tons per hour. So we're going to talk about the 100 now. Because what does the 100 represent? The 100 represents the plant processing crowd. So is my 98.140 less than or greater than 100? So if that 98 is less than the rate that it's being processed at, is the amount of gravel going to, unprocessed gravel, going to be greater than or less than the amount of processed? That's where the 100 comes into play.
Because I had like the 98 and I was like, oh, I don't know what's up.
So yes, so what that means is that, all right, the gravel is increasing at which it's being unprocessed. However, it's not increasing at a rate greater than it's being processed. Okay. So that's good news though for the plant, because what that means is that the plant is more efficient. The rate at which the gravel is arriving is being taken away and processed quicker. So it means that there's not an excess. So like that's good news. That like shows efficiency. So is the amount of unprocessed gravel at the plant increasing or decreasing at T equals 5? So in this case, since G of 5 is less than 100, the amount of unprocessed gravel is decreasing. So again, G of 5 is less than 100. Therefore, the rate at which the gravel is being processed is arriving is less than the rate at which the amount of gravel is being processed. Therefore, at T equals 5, it is decreasing. That was hard to say. And then the max and the min. So the max and the min is your EBT. That's your candidate's test. So I need to know hour 0. I need to know hour 8. And then I need to know the extrema between them. So it says, what is the maximum amount of unprocessed gravel? So I want a max of unprocessed. So what you want to do is look at the amount of gravel that is processed or unprocessed. So I need to create that amount of gravel processed function. So A of t is the initial condition. So you started with 500 tons. It's arriving as G of t, right? So arriving as G of t. But we're taking it away as P of t. So you're adding gravel at G and you're taking it away as P, which is that 100 dt. So again, I need 3 key points. I need the initial to 0. I need hour 8, which is when they shut down. And then, what other time period would I need? Well, I would need when the derivative A is at max. So I need to know when A prime of t equals 0. So I need to know A prime. So the derivative of 500 is 0. Derivative of the integral becomes that function. So you get g of x. Derivative of the integral becomes the function. So you get so I need to know essentially what g is 100. And based on the fact that g of 5 was 98, I'm going to think it's the year 5, a little bit before or a little bit after. So again, g of x should already be in your y1. So then in y2, I put 100, and I would find the point of intersection. So g of x is in y1, 100 is in y2, and I want to show you guys something cool I learned yesterday that I did not know. Okay. So if you put g into your function, it would be helpful if I plugged in my document camera. Okay, ready? So, I learned this cool, nifty thing yesterday that I did not know. So you know how like we always, when we want to get to our y1s and our y2s and we want to put them in our equation, I had to hit like vars, y vars function y1? There's actually a shortcut. And I just learned it yesterday and I'm so excited. So if you go here, let's say we wanted to find that integral. Well, you know what? We have to do integrals. Never mind. Let's go to our graph. So what you'll see on here is like my window is going to be super insufficient. So here's my g of x function. It's up and down. It's up and down. But I didn't change my window. So I needed my window to kind of max out at like 8.5.
because I know that I can't go beyond hour 8. So I don't really care what's happening after that. So I'm going to go just over to hour 8 and only take that intersection that happens on this part of the curve. So my two graphs intersect. I hit second trace, go to intersect. Honestly, you don't even have to really move this to get to that close. Just hit enter like 3 times. So here's what's super cool. This value right now is now stored as X. This value is now stored as X. So if I hit second quit and I go to like my main screen and I hit X, it stored that value. Why is that cool? Why is that important? Well, we want to integrate the function A that is represented by 500 plus the integral from 0 to that X value. And we want to integrate G. G, look at this, ready? You can now hit alpha, trace, and there's Y1. How cool is that? You don't have to hit vars, y-vars function, and Y1 anymore. And then I want to subtract from that, math 9, 0 to X again of 100 dx. So this is going to represent in my table the middle of the candidate's test. So this is like the X value. I want to also look at 0 and I want to look at 8. So at that 4.9234, it's at 635. Okay. And then we also want to look at or take into account 0. So you're just going to go right back up to the function you already stored on there. And then change all of those top x's to 0. What do you know about integrating a function from 0 to 0? You just get the initial. So that makes 0, 500. Then we're going to go up and do it one more time. But instead of 0, we're now going to go to hour 8 when they close. And we get 525. So again, in terms of this problem, we were looking for what is the maximum amount of unprocessed gravel. So all of these values represent the amount of unprocessed gravel. So the maximum amount of unprocessed gravel is 635.376. When does that occur? It occurs at hour 4.9234. Does that make sense?
And then the units on that 635 number will be tons. So, do we want to talk about 14? Yeah. So in 13, we would do method 1. We would not look down here at method 2. So you would go from 0 to 3. You would integrate that function on your calculator and get 14 thirds. Yeah. Yep. And then part B was very similar. In part B, you were just taking that value and taking that initial 30 and adding to it the area under the curve. And then part C, again, 2 different ways you could go about doing it. My guess is we have method 1. We don't know the plus and stuff yet. So we have to show the fact. And then part D is exactly like the gravel problem we just did, where you have to find the derivative, set that equal to 0, find that time at which it occurs, and then talk about, okay, what does that mean? So at time t equals 63, the derivative is positive. Well, if the derivative is positive, then that means increase. If it's negative, then it implies decrease. Therefore, the original function at 63 is a max, because it goes from increasing to decreasing on the derivative. Okay. And then the beginning problems for this homework answer are here. I'll give you a second to check 4 through 11. And then anything you missed, you can do. The rest of that part, any answers? Most of these, and most of them on your test tomorrow, calculator problems. Tomorrow's test is actually one of those weird tests that is not split like evenly, or I mean, it's split more evenly. It's not like the fast test where it's usually a lot more non-calculator. Tomorrow, I think it's like a front and back no calculator, a front and back calculator. Like it is split very even. And a majority of the no calculator questions are like the fundamental theorem of calc questions, where you go from like 0 to x and you plug it in, and then x is something other than x. Like both that and then the majority are like doing problems where it's like a number to a number on the non-calculator part. And then what you ask for. Yeah.
So most of like the what like all like this page.
Like a read in, read out is going to be a calculator. Yeah. Okay. There's a pretty comparable read in, read out calculator. I was like writing it this morning. It's like currently unformatted because like I like copy and pasted like 2 tests together because I like changed things for this year. So I just need to like print it, but like I'll get it done right either QRT or and we have to start 6th period unfortunately. while we wait for that to turn back on, I do have like another practice handout that I was going to do with you after we went over. But why don't you just take like 3 or 4 minutes and try the multiple choice problems on the thread? In this first multiple choice problem, we have the derivative of the integral. Remember that the derivative of the integral is like inverse operations. So if you were to actually integrate that, you would end up with like the antiderivative of this with x, and then the antiderivative with -17 plugged in. So that -17 plugged in would become a constant. Derivative of a constant zeroes out. And then the derivative of the antiderivative would get you back to the original. So our answer choice needs to be x cosine x squared, or option number D. All right. Number 2, very similar setup. This time we have f of x equals blah, blah, blah. Find f prime. So again, asking you to find f prime is the same as asking you to derive this function here. So we know if we take the derivative of the integral, we end up with the answer x plugged in for every t. So we're going to have e to the 2x sine squared 3x, or multiple choice option A. Feels a perfect so far. Okay, number 3. Okay, number 3 sets you up as a trick. What's different from 2 to 3? Here we have a bound with an x in it. Here, both of my bounds are numbers. So if you take the derivative of numbers, that makes this answer here. So if you were to actually integrate that, right, you would have 2t to the 4th over 4 plus 3t from 1 to -3. So you would plug those numbers in. That makes all of this just equal to some constant. So then if I asked you to take the derivative of a constant, the derivative of a constant would become 0. So my answer is E. My answer is E, not A. The answer is E.
So if we have one where it's like, if the final number of Avogadro isn't x, or no, it's going to be 0.
Yes, ma'am. And then number 4 was a calculator question. So again, I put that function in my y1. You're going to look at this, and this is the one where we had to do math 8, and you had x, and then inside there you did math 9. But when you integrated, you had to make sure you put your 7 and your upper bound as x. Then teaching you that new trick, you're going to hit alpha trace, and you can insert y1 from dx to x equals, and then this is where you're going to put in 5 pi over 2. And we get 61.685. We feel good and confident about the multiple choice problems. Fantastic. So then what I want to do is, we are going to go through this, but I want to go over our homework answers first because I might give you like 10 minutes to try that problem on your own. So going through our homework solutions, on the chapter 5 review, you had to sketch a graph. That meant you needed to find all of the heights. So our curve was 4x minus x cubed. Plug that into our y1. Get our increments at a half. So 0, a half, 1, 1.5, and 2. Left ram, you got 3.75. Right ram, 3.75. So looking at left ram, this one's really below, a little bit above, a little bit above. So because this graph is concave down and this whole segment is below, this is still going to be an underestimate. Same with here. MRAM, because most of these are more above than they are below, MRAM would be that overestimate. And again, if you really wanted to know, you could actually integrate that and find the actual value. So the actual value would be that integral from 0 to 2 of 4x minus x cubed. So it would be like 4x squared over 2, so 2x squared minus 1/4 x to the 4th, and the actual is 4. Using a trapezoid, we get 3.75. Again, you can see all of those are below for the most part, so an underestimate. And then, like I said, you can actually integrate this, find the actual, getting that 2x squared minus 1/4 x to the 4th, and you get 4. So, mean value theorem. Mean value theorem is a fancy way of saying the average value. So the mean value theorem for integrals says that you integrate that function, you find its average, so that's the 1 over b minus a. So I integrated from 0 to 3 of x cubed dx and got 81/4. 81/4 represents the integral value. The average value is a third of the integral value, which means on average, the area under the curve is 27/4. The mean value theorem says that at some point C, the original function x cubed will equal 27/4. So then what we do is we say, okay, f of c is c cubed. I want to know, when does c cubed equal 27/4? So I take the cube root of that, which gives me 3 over the cube root of 4, which is approximately 1.889. If it was a non-calculator, you would stop here. Calculator gets you that answer to 3 decimals. Does that help with like mean value, average value? So again, you integrate, you take the b minus a and divide it, because mean value means average. Average means taking the sum of all the parts and dividing by the number of parts. So here my number of parts is that b minus a. So same with these 2 examples. So again, you can see these if you like unstaple your packet. These are on that inside. So here's 2 more practice problems with like their answers. But again, average value is 1 over b minus a. So in this case, 3 minus negative 3 integrating from a to b over that interval. So we're going to integrate 9 minus x squared dx to get 6. So that means the average value is 6. If I ask you for the c value, you have to set the original equal to 6. So that, like this question here is like a follow-up to the average value. The average value is 6. If I followed up to that, the mean value says that f of c, which in this case would be 9 minus c squared, equals 6. And then if you wanted to find c, you would subtract 9 to get negative 3 equals negative c squared, divide by your negative 1, and c equals plus or minus the square root of 3. But in this case, both of those live in my interval. So both of them are my answer. Does that make sense? Fantastic. Okay. Then these are my suggested textbook problems. So if anybody thinks they need extra review tonight, those are kind of like me looking in the textbook and I said, okay, here's each different type of problem. What could you possibly maybe need, work on? So, and I also organized them by what type of problem. So like if you know you're struggling with FTC, then do 39 to 42. If you're struggling with integrals, 25 to 29, so on and so forth. Let's go back now. And what if I give you... So what I really like about this problem is that it is a fundamental theorem of calc at its finest. So it tells us that the graph is differentiable. It tells us that we have a closed interval. And then it says that the graph has a horizontal tangent at x equals 6. So that means that right here on this graph, f prime is equal to 0. And then we are given that g of x is equal to 5 plus the integral from 6 to x of f of t dt. So this is our fundamental theorem of calc. This is like saying f of b equals f of a plus the integral from a to b of f prime of x dx. So in terms of fundamental theorem of calc, g of x is like my f, 5 is like my f of a, where a matches the lower bound. So what that means is that g of 6 equals 5. So part A, question 1, said find g of 6. So g of 6 is equal to 5. And if you had done it the long way, it would have looked like g of 6 equals 5 plus the integral from 6 to 6 of f of t dt. And again, we know any integral that has the same upper and lower bound is 0. So that is another way you could have gotten g of 6 equals 5. Then it asks you to find g prime of 6. So that meant I needed to find the derivative of g of x. Well, the derivative of g of x is like the derivative of this. So the derivative of 5 is 0. And then the derivative of the integral from 6 to x of f of t dt. So then you get g prime of 6 coming from the derivative of g of x. Well, the derivative of 5 is 0. Derivative of the integral becomes that. So we get that g prime of x is equal to f of x. So what that means is if this is the graph of f, that's really like saying that that is the graph of g prime. That's the graph of f. That's really like saying that's the graph of g prime. Which means that if f prime equals 0, g double prime equals 0. And that's going to come back into play. So g prime of 6 is like finding f of 6. F of 6 is at 3. And then g double prime of 6 is like f prime of 6, but they told me that f prime had a horizontal tangent at 6, which means that it's 0. If it wasn't at 6 and it was at any other point, then